My name's Chad Huff. I'm president of H&H Metals. So I've been in family business ever since 1980, and Ma and Pa started it, and I've been working here ever since I was, geez, don't tell anybody, but probably 8. Primarily, we are a job shop that caters to the construction industry. With that, primarily glass and glazing contractors. But we do work for metal roofers, we do work for drywallers, I mean, anybody that needs like sheet metal type stuff. So we're primarily sheet and plate based, but we do handle some lighter structural type stuff. We do have a welding department. But it's kind of like a full service type shop. Most people, when they think of metal, they just come to us. Well, a lot of the glazers were asking us to build inserts that go inside their extrusions. And those extrusions are designed to hold glass. They're not designed to hold steel, right? So they're asking us to put an insert in an oddly shaped steel, or a steel insert in an oddly shaped aluminum extrusion. So how we were doing it before is, well, they would say, we'd measure out the extrusion, and it was like, okay, we need a piece that's 1 3/4 wide by 3 3/4 long. Well, the mills don't make that. So from that standpoint, we had to get a 20-foot long bar of this stuff. Well, how are we going to do it? Well, before it was like, well, we have a manual, like I said, not a machine shop, manual mill, 3 foot at a time, a lot of repositions. You can imagine the hours we spent. So we said, okay, let's get smarter about this. Let's make it on the laser. So, if that piece had to be 1 3/4, we'd cut an inch bar, laser cut it around. We'd cut a 3/4 bar, put some holes in it. We'd lattice the 10-foot pieces apart. We'd weld the whole thing together. Well, when you introduce heat to a bar like that, it's crooked as a, you know what. So from that standpoint, it was a challenge trying to get those things to insert into an aluminum extrusion. So one of the main reasons we bought the Flex was to be able to mill really long bars and get them dead straight. Some of the things that kind of came out of the machine that we didn't even realize was how fast the machine really drills. And we're gonna show some of that to you guys here. We're gonna do a job where we're still making little parts, which you could absolutely make little parts in a mill. Machine shop. How we were making them before is we would take an extrusion, we'd saw cut it up like a loaf of bread. We'd have some little channels that were, say, 1 7/8 wide, have 3 holes in it. We'd be manually cutting piece by piece, drilling those things out. And they're having big burrs off of them. Then how do you get the burrs off? Well, now we have to vibratory mill them, and just kind of on and on. We would spend hours and hours and hours in front of those mills. So what we've done now with the Flex and the ability is we lay the whole channel before we cut it on the Flex, drill all those holes, then take it over to the saw and then cut them off like a loaf of bread. Now your part's done. There's no burr, it's done. It's a lot faster. You're gonna see how fast it really is to drill those holes. And then, the beauty of it is we're actually gonna throw a part in there that's a lot bigger than even our Flex. So this part's a 300-inch part. We're gonna throw it in, we're gonna drill it out, and then you're gonna notice we're not gonna be able to get the holes all the way to the end. We're gonna go saw cut it, and then we're just gonna stick it right back in the Flex, drill some more holes. And so that's kind of the beauty of it is it's a really efficient way to get holes in these parts. So that's one thing the Flex does really, really well. Super easy, and I will tell you it from this standpoint. Me going in there, not a machinist. I mean, I went into that class, 0 machinist background. The machining that I've done were little 1/4-inch bits and a router. So we were running much smaller tool holders. I mean, I kind of knew how to insert a tool and things like that. But I understood a little bit of G-code. I mean, nowadays programs pretty much write the G-code for you. You need to understand what it does, which the class does a very good background of how it works. But you'll be amazed with how much it follows other machines that are totally even different machines. So I would say if you have a machine that does G-code, you're probably going to be second nature at this. This is just it's just got bigger numbers. That's basically what it boils down to, is it's longer. But from that standpoint, the programming of it, that's probably the hardest thing that we dealt with, is just not having that machinist background. I mean, I'd never trammed a vise. I never even knew what that meant, because we never used vices, ever. Everything we used was suction down and cut around a sheet. So, we had to, we were from square one learning how this worked. And we went into that class, we spent a little bit of time with Aaron. And I would say we had a classroom session that might have lasted I don't know, an hour, hour and a half, which was mostly just review because it was mostly G-code type stuff. And then we went out into the shop and got to play on an actual machine, which was really cool to be able to like, hey, we're working on the machine that's going to be our machine. You know, when we bought the machine, the purchase of the machine wasn't, what's the return going to be on our investment? The return, the bigger question is how do we take care of this customer's problem and keep them returning? Does that make sense? So pretty tough thing to really put a dollar on it. I mean, I will tell you this. I mean, we've run jobs through it where, I mean, we ran a little threshold, and this is going to sound silly. We had a threshold to do out of some stainless steel, and it was a piece of 1/4-inch plate, and we've done 2 of these now for a customer, and they were only about 4 feet long, okay, which on our manual mill is a change, right? Like, because it's only 3 foot. So we had to literally put a ball end mill and do a groove every 1/4 of an inch down this plate on a 16-inch wide threshold, okay? We did this job the first time. We milled on that plate manually. I'm gonna say it probably took us almost a week to go through this thing manually. Multiple passes, multiple lines. We just recently got to do another one of these for the same customer, and we literally chuck it up in the Flex and hit go and come back an hour and a half later and the thing's done, right? And you almost feel guilty like giving them the bill, like, well, why was the first one so expensive, right? Like, and it's from that standpoint. Like, I mean, it's just, we found a better way to crack that egg. And that's really what it boils down to. So, we had a job we were doing where we had some extrusions that were about, it was a customer's extrusion, it's a fancy looking thing. I don't even know what it was for, but I think it was to hook a curtain wall up to a building, like a big window system up to a building. And they had to have some slots milled in them, I think, to anchor them to the concrete. And well, how do you get these slots in them? And where the slots were positioned, they were too close to punch conventionally. Like, you couldn't get the punch in far enough. So it's like, okay, now we have to mill the slot. Well, how are we gonna mill the slot? Okay, so we immediately thought, let's see what the Flex can do. It was pretty cool, especially on the way that the open bed design works, because we have a bunch of vices spaced out about every 2 foot. And what we did was just stack apart, like in each vise, and you could start on one, and I programmed the whole table to be milled. And it would start milling the slots. And while it was milling the slots over here, I was still putting the parts in the other vices. The machine's running along. Well, as it gets coupled down, now you can jump over to the back side of the machine and you can start taking off and replacing those parts. So when it's finished down here, you hit start, it goes back over and starts cutting your parts. And now you can finish taking off those last 3 or 4, and you just basically chase the machine around all day. I will say it makes for a very, very tired operator, because it's a lot of spindle on time. I mean, how much can you say on a machine where you can have that spindle almost running complete the entire day, and that operator's just chasing his tail, pulling parts on and off of it? Where if I were to do those parts on a conventional machining center, there's a lot of spindle off time. And matter of fact, there's probably more spindle off time changing parts in and out than it is milling the holes. So you eliminate that. That's what keeps you to where, I mean, like I said, we're a single shift operation. We put out a lot of work for the amount of people we have. But I will say that it was kind of funny. The only time I ever really saw the machine stop is like when the operator needed a break. Like, you know, like, I mean, that's really, it's kind of funny. It's like, well, why is the machine not running? Oh, because the operator's in the bathroom, or he went to go get a drink of water, you know, and the machine's waiting on him. Like, you know? I think the favorite thing I have about the Flex is just watching it drill. It literally is to the point where it's almost scary how fast it drills. To watch, I've for years and years and years been doing it manually and seeing it, but I mean, when you watch one of those drills go through, and it can be a solid block of steel, it can be aluminum, whatever, and I mean, it's and it's done. It's like, you're almost like standing back waiting for the thing to explode. Like, it runs so fast. And I will say that I've never seen anything drill that fast. And that's really, like, when you watch something, if you're ever wanting to watch a mill do something, it's not the milling, it's the drilling that's really impressive. So that's probably the biggest surprise I've had with the machine. I would definitely recommend, if you buy one of these machines, definitely go to the class. Just get to meet you guys, get to see your facility, see how you guys operate. I mean, I think your guys' company, you would make a lot of companies envious. And if anything, from that standpoint, it was good for me to go see that, as a leader here, because it's like I love getting to tour other people's facilities, seeing the new ideas, and like you said, you guys are kind of the Google of machine tool manufacturers, and I love it. I mean, I love going in and you know, I mean, you get to the stuff where, like, I mean, we got involved in a ping pong match when we were out there, you know, like got to ride the Humvee around and, you know, all kinds of fun stuff like that. But it isn't just that, everybody's real friendly. I mean, it just seemed like a lot of camaraderie. You get to meet the guys that work on the machines, build the machines. You get to work on the guys that help program and help troubleshoot the thing if there is problems. I will say we are very fortunate. We've had to very rarely call tech support, but most of that is you know, we try to solve the problem here before we become a nuisance to you. But from that standpoint, very responsive. Just you can just tell the people care. And so I would say definitely take that advantage. Go learn, even if you're a seasoned machinist, you understand machining inside and out, at least go see the facility, see where they're built. And you might be surprised what you pick up there.